did go over that, but there's only 2 of these here, so I'll go ahead and go over these quickly as well. So here we're going to graph this. So the best way to figure out how to graph it is by creating a table. And the first thing we want to do is find the center line. We call that the axis of symmetry. So remember, the axis of symmetry is negative b over 2a. So in this problem, a is 1, b is 2, and c is 3. So I'll put my b value here, that's 2, and my a value 1 here. So that's x equals negative 2 over positive 2. And it does say to show your work and the table of values used to determine the graph. So I probably could figure out which graph goes through negative 1. So like, for example, the axis of symmetry of this graph here is at 3. So this would be x equals 3. So I know that doesn't work. So we can cross that out. On this one here, my axis of that line of symmetry is through negative 1. So that matches up. Oh, but this question also shows an axis of symmetry that goes through negative 1. So it could be either one of these two. And then the last one, the axis of symmetry is through a negative 3. So, okay, it's not that one. So in order to determine which of these two graphs is correct, you can make like a little table here. Remember, in the middle of the table is where we would put the x value here. And then you could do like 0 and 1, and then you could do like negative 2 and negative 3. And all you need to do then is plug in your number x into your original equation. So we would get, let's see, parentheses, so negative 1 squared plus 2 times a negative 1 plus 3. So that would give us a value of 2. So 2 here. And then you could figure out these two numbers, or these numbers here, by plugging in the same way. So plugging in a 0 instead, or plugging in a 1 or a negative 2 or negative 3 to figure out the numbers. So if we're looking for negative 1 comma 2, that would be this point right here. This is negative 1 comma negative 4. So we know that C has to be the correct graph for this equation. We'll try that again on question 14 as well. So x equals negative b over 2a. So b is negative 2. A is 1. So that means my numerator, negative, negative, is positive 2 over positive 2, which is just a 1. So that means my center line is going to go through positive 1. So this goes through negative 1. Okay, it can't be that graph. This goes through negative 2, can't be that one. So it's one of these two, because this is center line is at, or axis of symmetry is at 1, and so is this one. So in order to figure that out, again, we're creating that table. 1 is in the middle, and then you could do like 2 and 3 after it, and 0 and negative 1. And this is just because we were practicing making full tables when we were doing this in class. So just having a full table here is helpful. So then what we would do is we would take 1, we'll square it, minus 2 times 1. That'd be negative 1. And so for our full table of values, if I plug in 0 to both of these, if I do 0 squared minus 2 times 0, that would give me 0. So I'd have a 0 here. And then I could plug in a 3. So let's do 3 squared minus 2 times 3. That would be 3. So the graph that properly matches would be 1, negative 1, so it'd be here. And then you'll also notice that at 0, 0, we have a point, and 2, 0, we have a point, and then 3, 3. And negative 1, 3, we have a point. So that's the graphs. On our next page, we have 2 more graphs, but these graphs are in what we call vertex form. So if I look here, vertex form, just a reminder for that, is y equals a x minus h in parentheses squared plus k. Remember, h comma k is the vertex point. And then the other thing that was helpful for us with this is if we know that's a negative, it's going to face down. So like this a value is a negative, this a value is a negative. So both of our answers for these two should face down. So you can already kind of eliminate some of your answer choices. So this will not work, it faces up. this, it faces up. So it's between one of these two graphs. And then on this question as well, we can eliminate the two graphs that face upwards, because when A is negative, it should face down. So our vertex for this equation, so it says x minus h. So this is the h, this is the k. So our h is 1, and our k is -3. And that it is positive 1, even though it says x minus 1, and that's because it's x minus whatever our h is. So if I were to put 1 in there, it'd just be x minus 1, which is what this equation looks like. So now we're looking for a graph that has a vertex at 1, -3. If we look at this point here, this is like 1, -3. Because if you notice, this is 2 units here, so this would be 1, 2, and then this is 2, so this would be 3. So this actually should match with it, because this one here, the vertex is -4, -3, so that would not work. So as long as you can identify and write out what your vertex point is, you'll be good on this question. And then same with this one. This is your h, this is the k. So x minus h would be 2, +3. So we're looking for the graph that has a vertex at 2, 3. Well, this one's -2, 3, so that doesn't work. And then this one is +2, 3. So this one is the correct one here. And we just have a few more problems. Ooh, I did not get my last page printed out. I'm going to do this on regular binder paper. These are the projectile motion questions. If you haven't done the last page, remember this is our toolkit, our Unit 8 toolkit. If you haven't done the last page of this toolkit, that would be really helpful. I made a video that goes over explaining how to set these problems up. All right, so question number 17. I have it here. I went over it a little bit in the other video that I created. So we have our equation y equals x squared minus 6x minus 40. And we're trying to write this in what we call vertex form. So your first step, and this is in your toolkit as well, steps to converting from standard to vertex form. That's on page 5 of your toolkit, so that might be a helpful place to look. So we're moving the c to the other side, adding 40 to both sides. So that would give us y plus 40. And then I'm going to leave a little space here because I'm going to write something after that, equals x squared minus 6x. And then the value that I'm adding to both sides is half of the number here squared. So it's add b over 2 squared to both sides. So the b is -6. So -6 divided by 2 is -3. And when I square -3, that's +9. So I'm going to add 9 here. I'm going to add 9 here. So on this side, when I rewrite it, it's going to be y plus 49. And then on this side, I'm going to rewrite this as a perfect square factor. So if you really needed to, you could go all the way back and create the box and diamond, but it will always be the perfect square that starts with an x and it has a square here. And then whatever number is inside of this parentheses, so it's -6 divided by 2, that would go here. Because what we just did when we divided this by 2 and squared it is we created this perfect square. And then your last step is just to add the 49 to both sides, or get y by itself, or sorry, subtract 49. So the y equals x minus 3 in parentheses squared minus 49. So that's question 17. And I'm going to do the last questions. This was from what I made the video on. And I made a little notes of like where you can find all of these problems in the toolkit video. And make sure when you're doing this test on CUDA that you like write down this first equation, because some students were saying that they had a hard time going back to look at the equation here. Okay. So toolkit, I'm looking at toolkit page 6, question B. So I'm going to go back to that toolkit. Let's just remind ourselves where that was. question B, it says, what is the height of the diving board or whatever figure we're looking at? So basically plugging in zeros for time. So if I look at this question, I'm going to plug in a 0 here and a 0 here. We'd say height equals -16 multiplied with 0 squared plus 96 multiplied with 0 plus 268. So then 0, 0, our height would be 268. So that would be there. This one was in our toolkit, it was question C. So looking back at this toolkit, oh, okay, the maximum height. Oh, okay, I need to do the negative b over 2a. So let's set that up. So my b value is 96. My a value is -16. So let me get my calculator. We'll do that. -96. And that's going to be divided by 2 times -16. And that's going to be 3. That'd be D. This one is also part of that same question. So now I'm taking this answer that I got here, and I'm just plugging it into this. So height equals -16, and then we have 3 squared plus 96 multiplied with 3 plus 268. Okay. Oops. I'm going to go over question 22 first, and then we'll finish with 21. Question 22 is similar to question D on my toolkit, okay, here. So it looks like I'm just plugging in, okay, a number 1 here. So whatever I'm plugging in 1 second. So I'm doing the same thing for this question. So this question is 1 second. So I'm looking at this equation here, and I'm just going to plug in 1 for that. So H equals -16, plugging in 1 squared, plus 96 multiplied with 1 plus 268. So just get our calculator out, -16 multiplied with 1 squared, really shouldn't change it, plus 96 multiplied with 1 plus 268, and that would be 348. Okay, and then I'm gonna stop recording really quickly because I can only put 30-minute videos.